let's have a look at water interacting with the ground. Here's a bird flying over a diagram that we're going to use to understand some of these features. This is what you can really think of. This is Shavers Creek Environmental Center of Penn State. This is a little stream that flows into Shavers Creek just downstream of the dark cliffy spot, which is well worth a visit if you get a chance. But we'll go back to our diagram. You know that usually it is not raining, so we'll make the rain go away. And now it's not raining, but you need water for drinking and cooking and flushing your toilet, so maybe you need to drill a well. If you start drilling your well, initially you're going through rock or soil that may be damp, but there is some air in some of the spaces. And at some depth you will hit water. You'll hit what we call the water table. Below that, you're drilling through rock or soil in which all the spaces are full of water. You can pump that water out and use it. If you were to drill your well closer to the stream, you don't have to drill as deep. The water table is sort of a smooth version of the upper surface, and the water table hits the surface at streams and lakes. Now we put the rain back in and ask what happens to it. A little runs off, more if it's raining on a paved parking lot, but in natural systems, only a little bit of this goes into direct runoff directly to the stream. Most of it, 2/3 in central Pennsylvania, starts to soak into the ground, but then it's grabbed by roots, or maybe a little bit just evaporates directly. Most of it grabbed by roots goes through trees. It then goes back to the air. We call that transpiration. Add in the part that evaporates directly, and it's evapotranspiration, and sort of 2/3 of the rain that falls in Pennsylvania just goes back up in the air where it can make new clouds and rain again. With 2/3 evapotranspiration, only a little bit runoff, that leaves almost 1/3 to soak into the ground, eventually move through those water-filled spaces over to the stream and down the stream headed for the ocean. Yep, there's a little coming in from the other side of our diagram too. When the water is reaching the water table, faster than it flows away, you'll start to fill some of those spaces that had air just above the water table, and the water table rises in elevation. If it rises all the way across, it can make a flood, and we need to know about things like that. Most of the time, though, water is not arriving, but water is leaving down the stream, and so you start to drain water out of some of those spaces, and the water table drops in elevation. If it drops too far, the stream may dry out. If it drops too far, your well may dry out if you didn't drill it deep enough, and you may have to find a different source of water. So back to Shavers Creek and a few of the things to know about water in the landscape.